Okay, we're going to continue with graphing linear style functions. And again, we have the same equations, but we're going to see a different method of graphing that we can use. So far, we have used two methods of graphing, using a table of values and using the intercepts. And now we're going to talk about a third method of graphing lines called slope-intercept form, which you are already familiar with. And if you remember, what does slope-intercept form look like? Slope-intercept form is y equals mx plus b. So the very famous form, y equals mx plus b, where m is our slope and b is our y-intercept. And we'll see in the use for graphing, I'm going to give you a couple different hints, maybe a trick, that'll help you graph a little bit better. And so we know what the y-intercept is when x equals 0. We know what the slope is. It's a rate of change, the change in y or the change in x. How can we use that to help us graph? So we're going to start with the first equation. So our first equation is 2x plus y equals negative 6. Now, can we use this equation right now? No, because it doesn't look like this. And as I talked about in a previous lesson, we have to make this equation look like this equation. So we look at our given equation, and what we have to do is get this y all by itself. So we want to solve this equation for y. And the way we do that is to get rid of 2x. And so how can we get rid of 2x? We can just take it away. We take it away from both sides. And when we take it away from both sides, we see that we'll have left y equals, now I can write this as negative 6 minus 2x. I can. But that will not look like slope-intercept form. So I'm going to keep the term with the x first. And that way, I have an equation that looks like it is in slope-intercept form. Now with our equation this way, we can identify a few key elements. The first is the slope. The slope is negative 2. The second element is the y-intercept. The y-intercept is negative 6. Okay, so we know these two elements from looking. Now with that, we know that we can graph. And here's what we can do. In a previous lesson, we talked about slope, and I asked you to describe it. And so what we're going to do is describe a slope of negative 2. And as you remember, slope being rise over run would be negative 2 over 1. And how can you describe a slope of negative 2 over 1? It will be down 2 and then right 1. And so that's how we can describe a slope of negative 2. It means a line that is going down 2 and right 1 for each unit. So how can we translate this information into graphing? So we have enough information to begin graphing a line. So we have y-intercept at 0, negative 6. We can start there. Why am I starting there? Because here's another way of looking at this equation. Y equals mx plus b. You can say that the b stands for begin. So you may want to begin at the y-intercept. If our y-intercept is at 0, negative 6, let's start there. So 0, 1, negative 1. Here's 0, negative 6. That's where we will begin. And then all we need to do now is move our slope. Describe using that slope description to move from there. So we can say that the m stands for move. So we begin at our y-intercept and we move our slope. From where we are, we can move a slope that is down 2, right 1. Down 2, right 1. There is our second point. Now, what we could also do is move in the opposite direction. We could also move up 2 and left 1. We could also move up 2 and left 1. Up 2 and left 1. Because we're going to be on the same line. So it doesn't matter which way you count your slope, you're going to be on the same line. And of course, we can sketch the graph. And this graph has been the same for all three methods of graphing. We could use table of values, we could use the x-intercept and the y-intercept, or we can use slope-intercept form. We will have the same graph. So it won't matter which method you use, but you'll have the same graph. Now for the second equation, y equals 1/2 x minus 2. As you can tell, it is already in slope-intercept form. So there's no initial work that we need to do. We can tell right away that the slope of this equation is 1/2, and we can tell right away that the y-intercept is at -2. And that's enough information to begin graphing, because remember, slope, we can describe this slope as moving up 1 and right 2. Okay, so we can use this information to graph. So we make our coordinate plane. And we have our y equals mx plus b, where b can stand for begin. We begin at the y-intercept of -2, and m stands for move. And so all we do is count our slope from there. And we will go up 1 and right 2 from there. Up 1 and right 2. And we can also move in the opposite direction, down 1 and left 2. Either way, it gives us a straight line, the set of all ordered pairs that would make this equation true. So we have our graph, and it doesn't matter which way we do it. We can use a table of values. We could use our x-intercept, y-intercept, the x-intercept at 4, the y-intercept at -2, or we can use slope-intercept form. But this is how we can graph linear functions.